This lesson deals with complex numbers and roots. We're going to define and use imaginary and complex numbers, and we're going to solve quadratic equations with complex numbers. Complex numbers can be used to describe zeros or quadratic functions that have no real zeros. So that means they're going to be imaginary. So if we look at x squared plus 1, you can see this graph, it does not cross over the x-axis, so there's no x-intercepts, so there's no real zeros. When we set it equal to 0, we get x squared equals -1, or x equals plus or minus the square root of -1. The square root of -1 is the imaginary number. The unit is I. We can write the square root of any negative number using the imaginary unit. So, looking at imaginary numbers. An imaginary number is the square root of a negative number. Imaginary numbers can be written in the form of bi, where b is a real number and I is the imaginary unit. The square of an imaginary number is the original negative number. So let's look at some examples here. So first off, the square root of -1 is I. The square root of -2 would be I root 2, or the square root of -1 times the square root of 2. The square root of -4 would be the square root of -1 times the square root of 4, which would be 2I. If we look at the square root of -1 squared, the square root of -1 is I, so it would be I squared, which is -1. So the important thing is to realize is I equals square root of -1, so I squared equals -1. So in algebra, if b is a positive number, I'm going to abbreviate. Positive, we'll say real number. Then square root of -b is I root b. And the square root of -b squared is bi, and the square root of -b quantity squared is -b. So putting this into practice, we want to first express all of our numbers in terms of I. So this would be the same as 3 times the square root of -1 times the square root of 16. The square root of -1 is I. The square root of 16 is 4. So this would be 12I. So we do the same thing here. Leaving the negative outside, it would be square root of -1 times the square root of 75. So -I, and then you have to simplify the square root of 25, or 75. So you have to think of that as 3 times 25, 5 and 5. There's a pair, so one comes out. The singlet stays in. So this would be -5I root 3. I'll work with the check it outs with you, just to help you out. Square root of 12. So this would be 2I root 3. So 2I times 6, 12I. And 63. So this would be 3 root 7. Negative 1/3 times 3 is just negative 1. We still have the I, so negative I root 7. Solve each equation. First thing you want to do is make sure that you isolate the x squared. So when it's already isolated, you're just going to take the square root of both sides. So x equals the square root of negative 81. And because we are doing an equation now, we do need to use the plus minus. So x equals plus or minus 9i. The numbers are always written in front of the I. So, again, isolate the x squared. I'm going to subtract 75, divide by 3, then take the square root. Remember your plus minus when you're solving an equation. So this would be 5i. Okay, so try the check it outs on your own, then come back and watch a video and see if you are correct. And hopefully you were able to get those answers. Okay, moving on just to one more part. Complex number is when we have both a real part and imaginary part. So a complex number is written as a plus bi, or a number and the imaginary part. Okay? So think of solutions now. We have something like 5 plus I root 3. That would be a complex number. Okay? So we also look at what's called conjugates. Conjugates are like their opposites. So if I have a plus bi, the conjugate would be a minus bi. So the sign in the middle is just going to be the opposite. So when we look at the first one, we need to write it in our a plus or a minus bi form. So this would be negative 15 plus 2i. Now to find the conjugate of that, the real part stays the same. Change the sign of the imaginary part. In the second one, we only have an imaginary part, writing as a complex. Change the sign, and then this would just be 4i, because we don't typically write the 0. So, to check it out, remember that you need to have it written in the a plus bi form before you can write the conjugate. So closing the lesson, I'm going to write the expression the square root of negative 12 plus the square root of 36 as a complex number in the form of a plus bi. We're going to identify the real part and the imaginary part. So the first thing I'm going to do is simplify this. Square root of negative 12 is square root of negative 1 times square root of 12, which is I, and this is 4 and 3. So that would be 2 root 3. And the square root of 36 is just 6. So writing that as the complex form would be 6 plus 2I root 3. This is the real part. And this is the imaginary part. And that's the end of lesson 5.5.